Today's podcast is sponsored by Do It. Reduce your cloud spend by improving your cloud efficiency with Do It, an award-winning strategic partner of Google Cloud and AWS. Find out more at doit.com. That's DOIT.com. Welcome to Day 2 Cloud. And in this episode, sponsored by Microsoft, it is November 2023, and I am in Seattle for the Microsoft Ignite conference. And if you think you've heard this intro before and you're wondering if you're hearing the same episode again, you are not. This is the second episode from Microsoft Ignite 2023. And today I'm talking with Pierre Roman. Pierre has been on Day 2 Cloud before, episode 97 from May 2021. We talked about Azure Cloud Networking Essentials. And Pierre is back to share some details about Azure Boost, which does hardware offload of Azure virtual machines, similar conceptually to what a SmartNIC does, how to implement security in Virtual Network Manager, as Pierre has worked with customers using it and has some tips, and then how to optimize your Azure observability. That is, don't blow up your cloud bill by spending lots of money needlessly on logging. I want to introduce the audience to you, even though you've been on the show before, but you have this title that to me seems vague. You're a senior cloud operations advocate. What the heck does that mean, man? What do you do?
What do I do? Well, first of all, I'd like to say that the title is better than what it used to be, where we were senior evangelists, the old term from Apple from 1980s. But anyway, so as a cloud advocate, my role is really twofold. I work within engineering, so I am engineering embedded, so work very closely with the product groups. My audience is like the IT pros, the people that are actually doing stuff. And IT pros, as you know, are risk adverse.
Yes, we are.
If it's not broken, don't mess with it, unless there's a reason why you want to mess with it to make it better. So I concentrate on like what can help them fix issues that they have currently. So I get the products, the messaging, the value proposition, how it can help them, how it can be integrated into their own stuff, because I will never tell a customer rip and replace. That's not my role. And sales hates me for that.
You're an advocate for not only the cloud services on the Azure side, but it sounds like also for the customer.
For the customer, because that's a second fold of my job, is once I've started to work with customers, and I work for customers at large. So if it's a small mom and pop shop and I happen to meet with the guy at a conference, we talk for half an hour, 45 minutes, but he tells me there's a blocker. I'd love to be able to deploy this, but I can't because X, Y, Z. Sometimes it's compliance issues. Sometimes it's just size. Sometimes it's just cost. So I bring that back to the product group because, you know, the product group, a lot of those engineers, they live in the Redmond Ivory Tower.
Yeah.
So sometimes what they design, which is really cool, when the tire hits the road, sometimes it slips a little. So that's my role, is to bring that feedback to the product group so we can make it better. So I'm an advocate to the users and to the product group.
Okay. So you're actually a good person to talk to. If you're out there and you get to talk to someone who is a cloud operations advocate, they're on your side. They're not there to just, sell you stuff. It's not about marketing. It's more like, here's part of our product set you can use to solve a problem. And then you can go back to them and go, yeah, but it doesn't work the way I want, or I can't make it work in this way for this reason. And then Pierre goes back into the bowels of Azure and says, look, guys, if we fixed it like this, the customers would be happier.
Yes. And sometimes they'll say we can't because of blah.
Right. Okay.
But at least now I can go back to the customer and say, there's an actual design reason why it can't be done that way. It's a lot easier pill to swallow when somebody's being told, no, you can't do it this way because it will break X, Y, and Z, versus, nope.
Well, let's get into some of the news that came out here at Microsoft Ignite.
It's been a busy week.
One of the topics is Azure Boost, which when you and I were talking before the show, you kind of explained it to me. It's like, it's a card you slap into the box, and it's going to offload a bunch of hypervisor functions in a hardware accelerated way. Do I have that roughly right?
Roughly. Like, let's go back to on-prem days where you had these massive servers and you would have these network cards that you could do like offloading. So all the processing, the encryption, and everything else was done by the card and not by the CPU. And making your CPU freer to do other tasks and basically accelerate your workload.
So my world is largely networking and SmartNICs, DPUs, data processing units, has been a big talker in that world.
Yeah, so how do you take that one NIC and apply it to 10 football fields worth of compute power?
So we're talking about storage offload functions, we're talking about network offload functions, et cetera, that are baked into this Azure Boost card.
Yeah, so this custom built or purpose built is the marketing world. I'm not marketing, but every once in a while I like the way they phrase things.
Yeah.
It's purpose-built especially for offloading networking and storage from your VMs from IaaS.
Although it's got more functionality than even that, because there's all the hardware TPU stuff, proving, validating that this is a legitimate process that's coming up. It hasn't been tampered with. It's been signed appropriately, and so on.
So that's kind of part of the trusted platform and secure boots and secure launch and all of these other things that they've been talking about this week. But in effect, at its core, it's an accelerator.
Yeah.
So offloading all of your network traffic and your storage traffic through this card, because that processing that through CPU is much more efficient on hardware than it is in software.
Now, as a customer, I am not consuming Azure Boost as a feature where I'm checking a box. This is basically Microsoft's internal engineering for the Azure cloud.
Yeah.
It is something that Microsoft is standardizing on within Azure?
I believe so. I don't have the luxury of sitting with Mark Razinovich on every other call to find out what he's thinking in the giant brain of his. Actually, I'm feeling kind of special because I'm sitting in the chair that he was sitting in an hour ago.
He was there very recently. Yeah, that's funny. Well, Pierre, I mean, my interpretation of the news that came out is that there were some statements that said basically, this is where we're heading for everything long term.
Yes, and it's being rolled out right now. It's don't have the percentage of regions, but it's not worldwide just yet.
Yeah.
It just kind of ended preview. Now it's being rolled out worldwide. In essence, what the people are deploying resources to it are really going to notice is faster boot, faster deployments.
That is me as a customer. I'm standing up an Azure virtual machine.
Yes.
It's going to feel faster to me.
Yes, because whether it's a Linux or a Windows box, you deploy a box, the first thing it does when it loads is detects its hardware, loads whatever driver needs to be. In some cases, if you're in an on-prem environment, you may have already created or shoved in your own specific drivers into your image that you're deploying, which is the way we do it in the cloud. So when you're picking an image out of the gallery, those are basically like sysprepped. And I'm using the term very broadly.
Okay.
They're kind of like sysprepped images. So we don't actually go through a whole installation. You're not copying one file at a time to the disk. You're deploying a disk that has that image, and on first boot, it just completes the installation. But now we don't have to worry about those drivers because they're unified. It's like this custom unified driver that will talk to your storage and your networking, regardless of what you have on the other side. So depending on the family of VMs that you have, you may be connected to, I don't have the numbers off the top of my head, but like, for example, a 10 gigabit versus a 40 gigabit for networking. So the high throughputs. Normally you'd have to replace or you'd have to get a new driver. Now that's gone.
Which would mean I'd have to have a new VM. I might have to reinstantiate the whole thing as a different flavor.
Well, when you resize a VM, there's always, majority of the time, the VM will have to reboot.
Yeah.
Because when you're resizing a VM that's running, you're now allocating like more CPUs, more memory, and the fabric will try to find that contiguous block of compute power and compute memory. And if it's not in the node that you're in now, then it has to shut it down, move it, and then turn it back on with the added functionality or added resources to it.
With the unified driver here, it's basically acting as an abstraction layer that I'm not so worried about the underlying hardware.
You're not so much worried about the underlying hardware for networking and storage.
Okay.
Everything else like CPU and memory stays the same.
Because, again, those are functions that are being offloaded to the Azure Boost card.
Yes.
Which, again, as a customer, I'm not even going to see this, but it's all engineering magic under the hood that is going to make my Azure experience a better one.
I'm actually actively trying to justify visiting an Azure data center just so I can see, because in my head is like, I have a card. Which server do I put it in? But no, I'm not looking at a server. I'm looking at a building full of compute power. It's not a server anymore. But I've been in the business long enough that sometimes I have to think to myself like, oh my God, I'm not looking at 12 U's worth of compute power. I'm looking at 12 football fields of computing power.
But my VM still sits on, ultimately, there's a node that it's going to find its way to.
Yes.
Yeah.
But you just don't know which one.
Right.
Like it just, wherever the node that has capacity for that VM based on the requirements that you have. So if you're picking a IN GPU for like the VM size that is associated with the IN GPU, it will pick the compute nodes that are closest or connected to those high-end GPUs. If you're using just a regular D4 VMs, then it'll just find open space where it needs to. But it's still that Azure Boost. I don't know if they're going to come up with some kind of acronym for it, but so far it's Azure Boost. Will be just applied to any machines running in compute in the regions where it's deployed.
Other features of Azure Boost that I was fascinated by, one is the way the networking plumbing is done. There are two interfaces on an Azure Boost card, and they're going to be dual home to two different top-of-rack switches. So if Azure is doing maintenance in a given data center and need to reboot a switch, you're still attached at 100 gigabits per second to the remaining tour. Yeah.
Typically in Azure data centers, it's never two. Most of the time it's three.
Okay.
Because if you have two and one fails,
half your capacity.
Not just half your capacity, now you have no more failovers.
Yeah.
Three at least gives you two more in case something else happens. Mm-hmm. And it gives you time to stand up a third one. But yeah, from what I understand, those cards are actually dual homed to two top. But the networking in Azure data center is so complex. It's just mind blowing on how they can route that much traffic to all of those, well, call them nodes, VMs, whatever, CPU workloads, majority of the time without any hiccups or downtime.
We talked about that to some degree with previous guests. Sarayan was on and shared how some of that's done with the way the capacity planning is done, the way the rollouts are done, keeping ahead of all of that at the global data center level, always knowing exactly not knowing exactly what capacity you need, but staying well ahead of it so that capacity is never an issue. It's a moot point, basically eliminating bottlenecks in the design.
Yes. But we never know what's going to happen. Like, I know that at the beginning of the pandemic, when everybody basically went home, there was a spike in resource consumption. So we were asked internally that if we had any demo workloads or anything like that to shut them down. Because some areas, some regions were like flirting with the lower limit that we're comfortable with.
I used to support just a comparatively very simple dual data center environment, and we were always looking at capacity as if, what if the entire data center goes offline for whatever reason? Can we do all our processing in the remaining data center? It was an active data center strategy. We had to do it that way. That's no choice, because what if?
Yeah.
And there was a day that it happened. It was a bad day, Pierre. It was very bad.
Oh, yeah. Oh, no.
So dual homed and lots of throughput coming off those NICs. The 200 gigabits per second of total networking throughput, which was interesting to me because it means they can fully power those NICs even in a virtualized environment. I remember reading a DPDK fully supported there is how they're getting that access to those NICs, so they're talking directly to that hardware. That's a lot of bandwidth.
Yes, it's a lot of bandwidth. I'm more impressed with the storage end of that.
So the numbers I saw were 10 gigabytes per second and 400K IOPS was quoted in one doc. Now, there was another link I found, Pierre, to the Azure Boost documentation, which was, you don't do anything on Azure Boost as a consumer, but they talk about all the capabilities.
Yeah.
The numbers in that document were even higher, 12.5 gigabytes per second of throughput and 650K IOPS.
The discrepancy in numbers, I think, comes from the fact that we just came out of preview. And as you know, when we go through preview, we're still technically in development. Preview is the new beta. So as preview evolves, we'll make tweaks. So depending on when that document was published, if it was published before the end of the preview or after the end of the preview, you're going to have slightly different numbers because we've made tweaks.
I mean, either way, the numbers are impressive.
Even the beginning of preview numbers, which were the 10 gigabytes and 400,000 IOPS, that's still pretty impressive.
Yeah, these are huge numbers.
Now, if somebody comes to me and says, well, my database is slow, well, that may be because the design needs to be reviewed, but I'm not a DBA, so I'm not going to go there.
Well, so, I mean, this is still a multi-tenant architecture. It's not like I, as a customer, am going to have, an entire box of metal with Azure Boost devoted to me and my one workload. It's still a multi-tenant thing, yeah?
Yes. However, I believe, and I don't deal with that often, but I've been asked in the past, there is capability to actually buy dedicated hardware within our data center.
Yes. Okay. So it could be possible that
it could be possible.
But the typical deployment is going to be, there's Azure Boost in the box and you don't even know it's there, but we've eliminated a lot. Basically, Microsoft's eliminated potential bottlenecks in the system by adding these offload cards.
It's bottlenecks in the system, but it's also migration from one node to another. because it's the unified driver. You don't have to worry about it. If you're going from a family DS4 or D4S or family, because different sizing of family will have access to either that 10 gigabit, that 40 gigabit, that 100 gigabit. Now you don't have to worry about it. You just reallocated CPU memory, but you're networking your drivers in essence inside that VM don't change.
Well, I guess we're still in a rollout phase with Azure Boost. That
Yes.
is, not every data center, not every node
No.
is got these cards in it, but that's coming.
The preview was announced, I think it was last July, but it didn't really hit the kind of like the news cycle. I didn't hear too much about it at the time.
If it came across my desk, I missed it. Yeah.
I think most of us probably saw it go by, but just didn't pay attention to it too much. But now that it's GA and it's like global rollout is going on, we're going to see some improvement. On the other end, if you're running a workload on a virtual machine that's sitting at 30% capacity, like you're only using 30% of what you already have, are you going to see a massive performance improvement? No. If you're pushing your capacity to near what is reasonable for that VM, so if you're on 80% of your network throughput or 80% of your IOPS are being utilized 80% of the time, now it makes this a little faster. So you may be able to like stretch that same resource and have some performance enhancement because of that.
There's a flip side to this. Like if I was running the data center myself or running a data center myself, one of the reasons I would want a smart NIC or some other kind of an offload card is it lets me let that CPU do other things.
Exactly.
So from Microsoft's perspective, you as Azure can now take more work in the same data center footprint.
Yes.
Yeah.
Yeah, so that's what I mean. If you're looking at upscaling your VM size, so you're upscaling your VM size because your CPU is bottlenecking, for example. Well, now if you've offloaded your storage and your networking, did you free enough cycles on your CPU that you don't need that upcycle? How much money is that putting back in your pocket?
Yeah, interesting.
And of course, I'm going to pull the consulting answer here. It all depends on what you're running and how you're running it.
Naturally. These cards, these Azure Boost cards, these are custom designed by Microsoft. This isn't any off-the-shelf thing. This is all proprietary custom magic.
Yeah. And as you saw earlier this week with our hollow-core fiber, the new silicon that we just announced, like we've been designing our own motherboards, not CPUs, but like we've been designing our own tech for quite a while. So now that's just an evolution of that process. And also that way, maybe we're not dependent on TMSC or any wafer manufacturer to provide Intel or AMD, even though there was some announcement with AMD processors, which I'm not too familiar with all of the details of. But when you're designing your own, like Apple did with the M chip on their consumer base, it gives you the ability to tweak where it needs to be tweaked because you know what your throughput, you know what your needs are.
When we get down into the guts of the silicon that's on this Azure Boost card, what we would see is silicon that's designed to optimize the hypervisor.
It's really what it's doing. It's offloading from the hypervisor, not necessarily from the VM, but from the hypervisor. So it's all operating at the hypervisor level.
The hypervisor software abstraction level that we would normally see would be presenting a layer to the virtual machines of storage and networking and so on. You've taken that layer, or at least some of the functions that are in that layer, and moving that into hardware is where we're getting the acceleration.
Yes.
I want to see that chip. I've always been fascinated by silicon and silicon design, and the way you can do the optimizations are just fascinating. And there's so many different ways to go about it. On the networking side, we have ASICs that are very optimized and have different pipelines that do certain things because of how you might need to rewrite a packet in a given way or swap in some bits in a header in a certain way and so on. You got FPGAs that can be programmed to do certain kinds of magic, very optimized for certain workloads. And now we've got, just flat out custom silicon written to do very specific things. And of course, things that are optimized for cryptography and so on. What a cool job if I could do that. I know nothing about that stuff, Pierre. I'm not that guy, but it's so interesting.
Oh, me neither. But in my workshop at home where when I build PC for my friends and for just like the regular like gaming PC type stuff, I have a wall because every time I blow a motherboard or I upgrade a motherboard and I have no more use for it, typically there's the domino effect. I upgrade my machine. Then my old motherboard goes into my wife's machine. Then that old motherboard goes into the kitchen machine. When it gets to the end and that motherboard, instead of sitting in the box, it just gets screwed on the wall in my workshop.
It becomes art. Yes.
It is. At some point, I'm hoping, but my wife isn't, that the wall is covered.
With boards? Yeah. And would it be art or would it be cautionary tales?
A bit of both. A bit of both.
I've got a modem I still wish I had. There was a lightning strike near my house, and it made it into the house, and I have the char marks on the modem.
Yep.
That's long gone. It ended up in the trash, but I still wish I had it.
Yep. No, I've got a few motherboards that are like that, where I tried to wiggle a cable and I forgot to unplug it. And then you see that little arc, and then you see a bunch of capacitors on the motherboard that are all black, and you see that streak on the PCB.
Yeah. Exactly. Okay, Pierre, back to Ignite content. We got now in my last conversation, we chatted about Virtual Network Manager and how you can build security policies at the umbrella layer above a bunch of VNets. Today's sponsor, Do It, can help you with your cloud challenges. Maybe you want to maximize your cloud use while controlling your costs. Perhaps the issue is balancing resource utilization while delivering agile IT. Maybe you just can't get good support from your cloud partners. Do It can help. An award-winning strategic partner of Google Cloud and AWS, Do It works with over 3,000 customers to save them time and money. Do It combines intelligent software with expert consultancy and unlimited support to deliver cloud at peak efficiency with ease. The Do It team knows multi-cloud, cloud analytics, optimization, governance, Kubernetes, AI, and more. Work with Do It to optimize your cloud investment so you can stay focused on business growth. Learn more at doit.com. That's DOIT.com.
If you're running a very small environment, 2-3 virtual networks, AVNM or Azure Virtual Network Manager, we love our acronyms, did I mention that already? Will help you, but you're not going to see like huge benefits because the environment's not that big.
Right.
If you're working in an environment where you've got like a development section or development subscriptions, and you've got production environments and production subscriptions, and you're looking at hundreds of thousands of virtual networks, and especially in the development environment where a workload will get deployed, tested, torn down, redeployed, tested, torn down, modified, redeployed. So those virtual networks are coming in and out of your environment. Well, those rules that apply to your virtual network, there's two things that I think AVNM does that are great benefit to the administrators, especially on the operations side. It's not so much on the deployment side, but on the operations side. Number one is topology. So I'm a big fan of hub and spokes.
Yeah.
Especially in the virtual environment.
Pretty common deployment where in this environment, the hub ends up being kind of the traffic cop, the gateway.
Your traffic cop, that's where you'll put like your firewalls, your application gateway, your virtual network gateway, so you could come in from express route, site-to-site VPN, point-to-site VPN into your Azure environment. So you come into the hub, and then from there, you're routed to wherever the workload needs to be.
Yeah.
Well, if you add a virtual network, AVNM, based on a set of criteria or a policy that you're applying to a network group, and a network group can be the name of the network. So anything that has prod in a virtual network name, then dynamically gets added to the group.
Yeah.
And then that group gets the topology rules, which means you're automatically peered to the hub.
You can do similar sorts of decision making with tags, I believe, right?
Tags is mostly policies, and it depends on your environment. So if you have an Azure policy that mandates a tag from production, development, blah, 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 so you decide what your tagging nomenclature is going to be. I'm a bit of a control freak with that because I manage our demo environment, our demo subscriptions. And I've got a bunch of policies. So all machines must have a shutdown time based on time zones, because we don't say 11 o'clock shut them down, because 11 o'clock in Seattle is not 11 o'clock everywhere else.
Right.
So we have policies that dictate that. And there's a policy for nomenclature and tagging. You cannot deploy a VNet or a virtual machine without a tag. And those tags, if it's a virtual machine, that tag is inherited by other resources like the NIC and the IP and so on. But the virtual network gets a tag by policy. So if you tag it production, dev, or anything. It could be in your environment. It could be finance, whatever, however you've organized your infrastructure. Because depending on who you talk to, some go by location, some do by corporate org chart. And who am I to say this one's better than this one? If it fits in your environment, do it. And you say, okay, but if you deploy a virtual network and it fits that criteria, it gets added to that group gets that topology rule.
Yeah.
Then to automatically full mesh peering or hub and spoke peering.
Right.
And you can have multiple policies for multiple network groups. So you can custom build how you want the system to manage all of those networks for you, as opposed to relying on the person deploying it to connect it to the right environment.
So again, we're at the virtual network manager layer, which is, I'm thinking of it as like an umbrella manager for all this, because what you set up high, you can't see me, people listening to this, but my hands are up high, is going to flow down into the VNets in that hierarchy.
Yes, regardless of whether or not it's like it's cross subscription. I believe it's cross tenant as well, depending on management group, but I can very well be wrong on that particular one.
So, good recap of the announcement. Now, you've worked with some customers that have actually been deploying this feature and have some guidance for folks that are considering using this.
Virtual Network Manager?
Yes.
Yes. I'm a big proponent of the hub and spoke, mostly because I like, and I just said that in my sessions, securing your IaaS environment with network monitoring. In the hub, I put all of my common services, firewalls, gateways, log analytics workspaces, because monitoring gets deployed everywhere. But one of the other things that AVNM, and we haven't talked about it, is the admin security rules. And that's the part that just became GA this week.
Yes, right.
So this is huge for environments that have distributed management. So you're in charge of the whole thing. But Bob or Julie in Chicago or in Montreal needs to set up a virtual network for a workload that's going to run for a few months for a campaign or whatever it may be. They create the virtual network and the virtual machines or PaaS or SaaS services, whatever they need. They're the owner of that virtual network. They can decide to apply specific NSGs. But you, because you're overseeing the whole thing, you define administrative security rule. That rule gets applied to that network grouping that we've talked about the same earlier. Mm-hmm. And then it pushes down a set of NSGs, network security groups, that cannot be changed even by the owner of those virtual networks.
The network security groups then are being created at two different levels. Are they additive, or is the higher up ones that I can enforce at the admin level now?
The admin rules.
They're going to take precedent.
Yes.
So it's not like that's a set of rules, and then if I configured some at the VNet level itself, they would also be applied. No, They are one set. The higher up set are the ones that...
It's a one set as long as the ones underneath don't overlap with the ones you've defined.
Don't overlap. Okay, so if they do overlap, what happens?
The admin security rule takes precedence.
And if they don't overlap, so wait a minute, both sets apply?
Yes, so if you're allowing from this, because NSGs is a port filter.
Yeah.
You know that. It's not a firewall, it's layer 3. From, to, over this port, this protocol, allow or deny.
Okay, so it's not like two different access lists and one or the other. It's I can have some applied down low, I can have some applied at the higher level, and they're going to mesh together. And if there's a collision somewhere, then the ones at the higher level are going to take precedence, meaning they can't do something I don't want them to do from a policy perspective.
Exactly.
Yeah.
Like, I'll give you a real-world example. Microsoft Corporate. Internal systems. We have a rule for any production workload that RDP and SSH are blocked by security rules. So if I create a virtual network and I put a few machines on there and I decide to RDP into them, even if I set up my own NSG and I say, allow RDP from here to here, nope, not going to go up. Because at the admin security rule, it's denied. Mm-hmm. So I don't have to worry about somebody doing something, because you've been in the business long enough. You know that some VP or some developer or some administrator will come to the IT department and say, listen, I just need this exceptions for just a few days while we're testing. You've heard that before?
Oh, yeah.
Oh, yeah. So, and then you go, talk to my boss. And then the boss, because he doesn't want to deal with it, says, Yeah, okay, do it. You know very well that once that change is made, that's permanent.
Yeah, it's even possible that I've written such exceptions for myself. It might have happened. I'm not saying it did. I'm just saying it's a thing that
I'm not
maybe
pointing
it
any
happened.
fingers here. And I may or may not have done the same in my 36-year career.
But it is, as you say, those things tend to become permanent.
Yeah.
Yeah.
So by setting that rule at a level where it will apply to all of those subnets based on your networking group that are dictated by either tag or name, or in AVNM, there's when you build your group, there's a number of different criterias you can pick from.
And this is also interesting if you're in a regulatory environment. You have to be able to demonstrate to an auditor to be compliant that
it's auditable.
Yeah, it's a good tool for that. Yeah.
You don't just show us like documentation. You can show here is the policy that denies it everywhere.
So any more tips for implementing that and these features, Pierre?
Start small.
Yeah.
Especially with the admin security rules. You can basically paint yourself into a corner.
How do you mean start small? Like pick a couple of target services and implement them first?
Yeah, especially if you have an environment that is near prod. You always have like your dev, your testing, your user acceptance testing in perfect conditions that are near prod.
Yep.
In the old days, we had this lab built with a bunch of leftover servers, and we told everyone that it was just like prod.
It's the same, but a little slower.
Yeah, but if you look at me right now, I'm doing the air quotes thing. That doesn't happen.
Yeah.
In controlled environment, you're going to have an environment that is near prod. Deploy it there. Like create that network group based on near prod or a UAT testing or dev or whatever you want to call it. I'm not dictating your nomenclature. And then deploy there. And then learn before you deploy to prod, and then all of a sudden your phone starts ringing off the hook, or the tickets on your email start like piling up.
Yeah, it's funny. You implement things like that, even with the best of intentions, or even obligated to do so because reasons. You're still going to upset a bunch of people who maybe were skirting the rules, not doing things they were supposed to do, and you broke something for them.
One of those exceptions.
Mm-hmm. Exactly. Yeah.
One of those exceptions that suddenly gets locked.
Yeah.
But like any networking or IT project, it's the last thing we think of is the communication with the stakeholders. What we're doing, how we're doing it, when it's going to be done, or remind you a month before, then 3 weeks, then 2 weeks, then a week, then a day before, and they're still going to cry.
Yes, I'm laughing. I've been through. I've done this dance. You write the notes, and it's like and then when they come crying, and you go, "You saw the notes, right? I didn't read them. There were too many words." Like, come on, man.
Too long, didn't read.
Yeah.
TDL. Anyway, well, the networking part and the screaming part, it always reminds me of the story of the scream method. When you have a large environment with lots of different workloads, and you say, "Who owns this workload?" and nobody ever owns it.
Yeah.
Until you go to the networking, and then you basically turn off that port.
Yeah.
Or just, if you've got access, just physically unplug it from the network. I never turn it off, because it happened once that it didn't come back up. It was an old workload.
And that disk just didn't spin again. Yeah.
It just didn't spin again.
Yeah.
So you unplug it from the network and you wait for somebody. It's like that. Somebody this week mentioned it and called it the whack-a-mole rule. Because when you pull the chip, somebody's head's going to pop up.
Okay, so start small with this, of course. I mean,
Yeah.
that's a pretty standard best practice. So you told me, you've been talking to some customers
Yes.
whose logging and observability stuff accounted for about 35% of their Azure cost. And there was someone else you talked to about a year ago was 60% of their cost.
Yes.
Because of all the stuff so describe what it was they were doing that was running up their bill so high.
So when you're looking at observability, it's really logging and monitoring and alerting, and it's all of that good stuff that we should all be doing in our environments, even on the networking, CPU, storage, all of that. Monitoring it, logging it, analyzing the logs to detect patterns, and then alerting the appropriate people based on those patterns. Mm-hmm. Now, to simplify this, if we look at somebody who's got a workload that's running on Windows VM, and you enable log analytics. So you have an agent that sits on the VM and basically feeds performance metrics, events, so your event viewer or logs, And any like IIS logs or any other logs that you may have created based on like a line of business application that was homegrown. Mm-hmm. So you feed that into your log analytics workspace, which is just like a gigantic database. You are built on data ingestion.
Okay. So in other words, the more things you log, the more events you're sending in, the more it's going to cost you.
Yes. And some of those events are free because they're built into the platform, they're built into the fabric, and it's just we want you, because we're managing it for you, but we still want you to be aware of some things happening here. But there are others, what we consider billable items, again, the air quotes. Well, no, they're not air quotes. They're actually billable items. But I've seen customers, and I'm suspect that person that was at 60%. So if your monitoring of the workload is more expensive than the workload itself, there's a problem.
Yes.
There's either a problem in your approach, a problem in your design, or a problem in your workload. Anyway, where they go and they say, okay, I want to know the performance of my VM. So they go and they create a rule to collect performance, and they'll say all performance counters, because that's an option.
Yeah, and of course you want to know everything, because
you need to know everything.
Yes.
And then you're going to go to your event viewer and you say, I want for system, I want my errors, my critical, my errors, my warnings, my info, and my verbose.
So all of them. Yes.
So all of them. And
yes.
Then you go to application and you want your critical, your errors, and then you go to authentication errors and you go, okay, I want the failed one, which I understand. You want to track if somebody's trying to log into local admin, you want to track that.
Yeah.
But then you're also going to pick successful. Is really knowing that Bob has successfully logged in, is it a critical thing for monitoring? Because you have to think, this is not historical data. We're not keeping this for audit for years. This goes into the data, into the log analytics workspace, which I believe by default is a 31-day window. Mm-hmm. So it builds up the data into 31 days, regardless of the size of that data, 31 days. And on the second day, the first day falls off.
So the point you're making here is the typical approach a sysadmin might take is to overlog events. Yeah.
Absolutely.
And that's not free in Azure.
No.
It's not free on premises either. You got to save those events somewhere. Something's got to be, but it's a less tangible sort of a cost.
Yes. The difference with on-prem and in the cloud, and it's the same for a lot of different workloads, is that on-prem you've already paid for the hardware. You've already paid for that disk.
Yeah.
Whether or not you fill it or not costs you the same.
Yes.
In the cloud, no, it's pay-per-play. You use that much, we charge you that much. If you use that much, we charge you that much.
Right.
And it's not a linear scale, but there's economies of scales depending on the licensing you get, the SKU of the service you get. Anyway, so when I'm working with one of those customers that said, okay, I'm at 30% of my bill, is we started to work together. We came up with, in the product group, with a series of queries, because the log analytics workspace is you can query it using KQL. So you can say, show me all of my billable data across time. And then you can alert it based on, if you've got a stable environment, your log is going to stay pretty stable. Chances are you're not going to end up with like a very big spike unless you've changed the way or what you're collecting.
Right.
Like if you're collecting all of the events for all of your servers, you're going to have lots of data that you're going to be collecting. You'll be charged a lot, but it's going to be stable across.
Yeah.
But if one day, you say on the 20th of last month, your storage of billable data has gone from 2 terabytes to 20 terabytes. I'm just pulling numbers out of my head here, but something's changed. If you wait till the end of the month, you're going to be charged for that 20 terabytes.
Something changed, as in not something is going wrong with the system so we have extra errors. Someone can change the configuration.
Well, not necessarily. Maybe somebody added 5,000 new VMs that you're now monitoring.
Okay, right.
But at least you know and you can go and check. But in most cases that I've seen, it's somebody changed the configuration because there was a problem with a workload. I'm not sure where the problem is. I don't have the existing insight to know what it is. So I'm going to turn on the logging as high as I can put it in the hope that it's going to show me the problem. But then I never turn it down.
Right. You forget reasons, yeah.
Because once an exception hits the ground, it becomes permanent or semi-permanent. So there's a separate set of query that you can say, okay, now that I know that something's happened, show me which resources are actually driving it. And then another query that'll say, like, what kind of data? Is it Kubernetes logs? Is it IIS log? Is it my Windows logs? Is it my sys logs from on the Linux box? Like, it'll actually tell you where that data is coming from so that you can go and tune it to get what you want in terms of, I need to know where my bottlenecks here or whether or not I'm...
Can I also alert so that if something radically changes in the amount of what I'm logging, the log volume goes up, I can get flagged?
And that's the beauty of KQL and the whole log analytics or the monitoring is that it's the same engine. So you could use that exact same query and put it into an alert and say, when the differential is 10%, or 20%, and it's sustained for a day or 12 hours. You decide what's important, because I can be here and talk about settings and thresholds all I want, but it's your environment. You know what your environment needs or what it should look like. So you decide what that percentage is. Every time you have any kind of monitoring and alerting tools, you need to tweak them. Mm-hmm. That is one of the most... used reason, or not used reason, but that's one of the most frequent scenario I saw back in the day of Microsoft Operations Management Server.
Yeah, wow.
Because people would deploy their management pack and not tweak them.
Yeah.
And in the managed pack, it said that your boot disk should have 25% worth of free space. But if you're looking at a terabyte's worth of boot drive, you go, I got 250 gigs. Who cares?
Yeah.
So you disregard it. And the next day you still get an alert and you disregard it. And then you get an alert and then you disregard it. What is the first thing you do? You mute the alert.
Yeah.
Or you delete the alert.
I've never done that either, Pierre. But in Azure, this costs us. This costs us is the point.
But in Azure, it costs you.
Okay, so guidance then, I can think of some takeaways here. One would be don't overlog, don't over alert, don't check all the boxes. But is there what's my baseline? On some level, it's going to depend on your specific environment, specific applications. You kind of need to know your alerts and kind of know what level you want to be at.
So that's when you have to be intimately aware of what the workload that's running on your machine.
Yeah.
And if we take a VM as a example, the workload that's running on that VM, is it CPU intensive? Is it memory intensive? Is it network intensive? Is it storage intensive?
And then pick the things like if it's storage intensive, if you had a measurement that could trigger on IOPS or throughput or something like that.
Throughput, IOPS, page reads, page written.
Yeah.
How long it stays in the cache. Like, is your cache overloaded? If your cache is overloaded, then you're waiting to write stuff to the cache because the cache can't write it to physical or to, in this case, virtual disk fast enough.
It's not different than any logging challenges that we've ever had. It's the same thing. It's just there's a dollar cost associated with this. And this is where it makes it, there's a payoff for the business if you spend the time to log what you need to log and don't log what you don't need to log. And truly, if you're troubleshooting a problem, need to turn it up temporarily, it is a temporary thing, not something you forget about. And then, the bill comes up and accounting knocks on your door after a couple of quarters going, this is really high. What's going on?
Yeah. And we've made some improvement into the product in Azure Monitor. First of all, there's a new agent that's currently available. That's been for over a year or so.
You were telling me about this before we hit record, that there's an old agent and a new agent. And if you haven't updated to the new agent, that's bad.
Yes, because the old agent basically just sent a lot more than it needed to. And the way it was managed, it was kind of like this monolithic kind of agent that did everything, but it was not very efficiently. The new agent is a lot more efficient, and it gets its rules from what we call the data collection rules. So you could have a data collection rules for like your SQL servers and another data collection rules for all of your front end, your IIS servers. And because you know what those workloads are, you can tweak that rule to only collect the data you need.
Okay. And so what is the name of the agent specifically?
It's just the AMA, Azure Monitor agent.
Got it. Okay. So let's get that updated for one thing and then spend the time to tweak those rules.
Okay. Those collection endpoints. And I will give you what those queries are. I'll give you my GitHub link. They'll be in the show notes. So feel free, if you're listening, to go and copy them and modify them for your own environments. They'll give you a really good start to kind of nail down what the culpable workloads on your networks are generating your cost.
Excellent. We will include the link in the show notes, as Pierre said. That's going to be at packetpushers.net for this episode. There is also going to be some other links. We talked about Azure Boost today. So there's an Azure Boost landing page and there's an Azure Boost documentation page. We'll link to those if you want to read up more on what Microsoft is doing with Azure and Azure Boost. Pierre, you're pretty accessible online. If people want to reach out to you, how can they do that?
The easiest way is on X, formerly known as Twitter, and kind of threw up a little bit in my mouth by just saying that. I'm, and always shall be, at Wired Canuck.
At Wired Canuck. LinkedIn too, I'm going to assume?
LinkedIn too, Pierre Roman in one word. And on Threads.
Oh, Threads. Oh, you might be the first one throwing down a Threads. I have a Threads account. I have not published a thing, but I have one.
I'm not throwing that one often too, because right now I'm in discussion. Somebody has stolen or is pretending to be me on Threads.
Oh.
Even using my profile picture and at Wired Canuck and links to my blog.
You sure it's not you and you just forgot?
No, it's not me because I can't get into the account.
Oh, jeez. Okay. That's not cool.
Because Threads is kind of linked to your Facebook account.
Yeah.
And it's not my account.
Wow. Okay. That's not good. Anyway, well, Pierre, thank you for taking time with us on Day 2 Cloud today. And our thanks to Microsoft for sponsoring today's episode. And thanks to you. You are the most important part of this podcast. So seriously, virtual high fives to you for tuning in, listening all the way to the end. If you have suggestions for future shows, you can hit me up on LinkedIn. You can find me if you search for Ethan Banks. And I'm happy to connect with really anybody. That would be great. I'd be honored to do that. If you like engineering-oriented shows like this one, visit packetpushers.net/subscribe. All of our podcasts, newsletters, and websites are up there at that site. Nerdy content designed for your professional career development. Our lineup of podcasts these days includes Heavy Networking, Kubernetes Unpacked, Heavy Wireless, Network Break, Heavy Strategy, IPv6 Buzz, and of course the show you're listening to right now, Day 2 Cloud. And of course we have even more free stuff like a Slack group, engineering blog posts, industry news coverage, and more. And I'll shut up with the housekeeping now anyway, packetpushers.net for all of those things. And until then, just remember, cloud is what happens while IT is making other plans.